Hello, everyone. We know that CNC lathes are controlled using data, and the two crucial pieces of data are the tool and the workpiece. And each of us, the position of the workpiece and cutter installed each time in the CNC lathe is different. So it's impossible for data to be identical all the time. So how does the CNC lathe solve the problem? Well, let's understand what tool setting is and its methods. Generally, programming and processing of a part are separately operated. Programmers set a workpiece coordinate system convenient for their work according to the design drawing. This workpiece coordinate system generally coincides with the process or design reference of the part. Develop part machining programs in the workpiece coordinate system. The essence of tool alignment is to measure the offset distance between the origin of the workpiece and the origin of the machine tool. To set the origin of workpiece and the coordinates of the machine tool coordinate system with the reference of the tool tip. Programmers must create tool trajectory programs based on the coordinate data in the workpiece coordinate system, which must be processed in the machine coordinate system. Due to the x directional offset distance and z directional offset distance between the machine tool origin and the workpiece origin, the actual tool tip position has the same offset distance as the program instruction position. So we need to measure the distance and set it into CNC system to make it adjust the trajectory of the tool. Only in this way can we machine the workpiece according to the part drawing. This procedure is tool alignment. In CNC turning, we should first determine the machining origin of the part to establish an accurate machining coordinate system. It's crucial for CNC operation. Meanwhile, we also need to consider the impact of different tool sizes on machining. Tool alignment can solve the problems. So, it serves as the basic skill and the fundamental of efficiency of the workpiece processing. There are many ways of tool alignment. According to the precision, it can be categorized into rough alignment and precise alignment. According to the usage of tool presetter, it can be divided into manual tool presetting and automatic tool presetting. According to the usage of reference tool, it can be divided into absolute alignment and relative alignment, etc. But all of them needs trial cutting for tool setting, because it's the most fundamental method. Well, let's learn the basic steps of tool alignment with the example of the 93 degrees cylindrical turning tool. First, manual zeroing. First, click the button of tool compensation to enter the tool setting. Second, click the buttons of manual mode and rapid traverse to make number 1 tool get closer to the workpiece quickly, and then cancel the swift motion. Third, move the tool in the negative z-axis direction to the left of the workpiece end face by 1 to 2 millimeters. Then cut along the negative x-axis direction to the center position of the workpiece. And at that time, the tool must exit along the positive x-axis direction, and there should be no motion in the z-axis direction. Fourth, find offset number 101 in the tool offset interface. Input Z0 and retract the tool. Fifth, Feed the tool in the negative direction of the x-axis to a cutting depth of 0.5 to 1 mm. Then feed along the negative z-axis direction. Turn around 10 to 20 mm. And then retract. At that time, the tool must exit in the positive z-axis direction, and there should be no any motion in the direction of x-axis. The mechanical coordinates of the tool tip in the lathe are equivalent to the diameter of the previously cut portion. Stop the lathe. Enter the measurement interface to measure the diameter of the cut part. Finally, quit measuring. Sixth, find offset number 101. In the tool offset interface, input the measurement value of x-axis and press Input to finish the alignment on the direction of x. Seventh, click the buttons of MDI and Program. After alignment, the way to enter the MDI operation is to input T0101. Press Cycle Start to use the supplement of number 1 tool. Eighth, verification of alignment. Press Position to display the interface of machine tool coordinate value. Move the tool manually to make it close to the workpiece. Observe the coordinate value displayed on the screen. And the correct way should be when the tool gets close to the right end of the workpiece, the z-axis value approaches 0. And when the tool gets close to the surface of the blank, the x-axis value approaches the diameter of the blank. Okay, this is the end of the class.